All right. So, as Jeff said, I'm François Ward. I'm tech lead of front-end infrastructure at HubSpot. And today I'm here to talk about how we scale front-end development through micro applications. So let's start by defining the problem that I want to discuss here. When you make a new application, it's small, and that's pretty nice. There's a lot of benefits to being small like that. Like your build times are really quick. You might be able to manage with a smaller team where it's a lot easier to handle people. There's not much tech debt yet, or if there is, its scope is much more limited. There's a lot fewer dependencies to think about. You might have less third-party dependencies. It's also a great place and time to experiment because the blast radius of those experiments won't be nearly as big. You won't affect as many people. But most importantly, you can kind of fit it all in your head. You can understand how an entire app works. Unfortunately, it really doesn't stay that way, and that's kind of the nature of the beast. When feature creep happens, or just as your application grows or your company grows, you're going to add more code, more libraries, more screens, and now your build times are no longer as snappy. You no longer have those 1 second start time that you used to have. You start having performance issues that you need to deal with. Your tooling, your editors, or if you like IDEs, those might start struggling if you have too much code. And you start having more people are breaking each other's builds. Generally, it's harder. So the question is, does it have to be that way? Is there a way that we can keep the benefits of being small even when we scale? And for that, first, I want to take a look at the backend world. Yeah, it's a React conference. I'm going to talk about backend. So first, I'm going to start with a buzzword there. Microservices. So I hear like a lot of people are familiar with it, especially in the last few years. That's a word that's been going around a lot. So first, let's define what that means, because it means different things depending on where you come from. So when we want to define a word, we go to Wikipedia, obviously, as the source of truth. So let me read this definition for you here. Microservices is a variant of the service-oriented architecture, SOA, architectural style that blah, 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 blah. So that's a lot of word that really means absolutely nothing. So for the context of this talk, I'm going to define what I think about when I think of microservices. So first, let's think about a more classical architecture on the back end, and we'll hand wave things a little bit. So a system is like a backend system used to be kind of monolithic. You might split it in a couple of pieces, and when I say a couple, 2, 10, you might have like a data tier, service, APIs. If it's backing a front end, you might have a renderer, you might have queues, you might have a couple of things, like 10, 15 services. There might be a lot of servers backing that stuff up, but you won't have like that many. And then DevOps happen. You have the cloud, you have AWS, you have Docker containers, and now it becomes much easier to deploy and to, essentially there's a lot less overhead to these services. And we're no longer splitting services or our system in 10 or 15. We're splitting them in hundreds or thousands. It's not weird to have like 10 services per developer at a company. You could have a service that has 1 or 2 APIs. You could very easily rewrite one from scratch the moment you no longer like it or it has too much tech debt. You could have one in Python, one in Node, one in Go. You could be experimenting. And generally, you can keep them all in your head. They're really tiny, very easy to manage. Tooling is a lot easier. The backend world has an advantage, though. Your users don't see it. If you went from having 10 services and you're moving to having 1,000, even if it's a endpoint that you're hitting, there could be a gateway in front of it. Your users will never have to know. There might be some increased latency or something, but there's even ways to deal with that. So on the front end, when we split things, it directly affects the user. So this is about how can we approximate what the backend almost takes for granted these days on the front end and how we do it at HubSpot. So I'm going to talk about how we can split a monolithic application, what that means when creating, building, and deploying those applications, how we streamline the development process when we go from a monolith to a lot more applications. I'm going to talk about the importance of style guides and libraries and to keep, how do we keep the world consistent. So, all right, first we have this big front-end system. How do we split it in the same way the back-end world does it? We're not going to split it in 2 or in 10. We're going to split it in freaking hundreds. So to give an idea, I was checking numbers right before coming here. At HubSpot, we have the HubSpot application is like 350 front-end application. We have about 100 front-end developer. This is not the same scale as the back-end people can do, but it's still like several apps per developer. So first, where do we split this without affecting the user? Well, first, keep separate products separate. Like your blog, it doesn't have to be the same app as a calendar, or our CRM doesn't have to be the same app as our project management. This, like in the world of monorepos and single page application, it might be tempting to be like, let's just make it another page in the same build. I won't have to worry about tooling and all of that. But let's keep those separate. Then, so some examples of that. So on HubSpot, at HubSpot, our account page is its own application, and our user profile, its own app. Someone's calling me. Let's ignore that. Settings are their own app. It's not just a page. Dashboard, its own application. Now, next, we're going to try to go even more granular than that. So think within those products where we can split things. So if you had like a master detail page or something, these could be completely distinct applications. Or like if you had tabs instead of just being like SPA transitions, like single page application or different pages, they could be completely distinct apps. So here we have our blog application where you can select a blog to view the details about it, and that's an app, and then the details is a different app too. Essentially, we have to think where our screen refresh is acceptable to our users and use that as a way to help us scale. There's other places too. Think stuff that's on every page that's going to be shared between all these applications. So in our case, the nav at the top, which is going to be the same across the entire product, for us, it's a different application too with its own build, its own theme. And our notification area, also the same deal. These are a little more complicated to split, and I'm going to get to how we do that later. So the goal here is that almost every app has its own repo. Like I know right now, like the buzz is to do monorepos and to try to bring as many things as possible together. We go the polar opposite way. We do have like some apps that have like a bunch of libraries, a bunch of apps in a single repo, but we try to split all of that, generally roughly on theme lines kind of. So now let's get technical here. We went from a single app, a single monorepo, to hundreds of repos so that we could get the benefits that a new application enjoys even towards scaling. But that does add complexity. So we'll get into how we deal with that extra complexity. First, we're going to be creating a lot of applications. This has to be dead simple. At HubSpot, we try to make it so simple that a new dev at HubSpot will create a new one as part of their onboarding. A real one that could possibly go to production. We generally only have it go to QA, but it would have all the pieces of a real production app with build, deployment, all that stuff. Even people that don't know JavaScript or backend dev go through that too. To be fair, we do the other way around too. Front-end devs do Java services. So the key here is to have a good application generator. You want to be able to create a new application from one command in seconds. You want to enforce best practices and all the things that are needed for an app in your company, for your system, from the get-go. All the common libraries and boilerplate should just be there right off the bat. It should make choices of environment completely explicit. Like, for example, we have external apps, internal apps, and stuff like that that need to be configured differently. The choice should be made from the get-go there, and all the configuration should just happen. Unit testing should be configured out of the box. You obviously want people to test their code, so you want to make that easy. There shouldn't be any friction there. And the Webpack configuration, we use Webpack, but whatever build tool you decide to use should be pre-configured. People shouldn't have to worry about that. So we use just a Yeoman generator to do that, and that works great for us. It just prompts you for all the options. We also have one for libraries. So if you make a new library, you go through the generator, and it configures it in the way that will work in our environment. But for my own stuff that I try to follow the same architecture, I've really liked Create React App for this. And for people that might not have used that, Create React App is this great tool where it's a single command, you create a new app, it has zero configuration essentially, and it just works out of the box. One thing that's really great about it is while it has zero configuration, you can fork it and make all the changes that you need, add all your Webpack loaders, your boilerplate, your libraries, and publish that to NPM, internal NPM, or a public one. And then when you run Create React App, you can pass the name of your fork as a command line argument, and it will use that instead. And then you can enjoy all the benefits of Create React App, but with your own customized environment. So if you decide to do something like that, that's definitely something to consider over like Yeoman. That's kind of the standard. All right. If it's that easy to create an application, it has to be that easy to build it. Otherwise, there's still friction in getting off the ground, and we really didn't gain anything. So first, when we're talking about builds, there's benefits to talk about when we just broke our app down. Our builds are going to stay super fast. We're going to have that much less code. If we split our app in 100, well, it's definitely going to be a heck of a lot smaller. So for building and stuff, you won't have to worry about scaling. It's going to much more closely match the teams. If other teams make changes, they're not going to break your build. And you, when you're making like complex refactoring, not only, as I mentioned, one of the benefits is that you can keep it all in your head, so you're much more confident in these kind of refactoring. But if you break something, it's only affecting the people sitting next to you, or if you work remote in your Slack channel or something. Now, what we make sure is that our builds are automatic and they're friction-free. All our repos, all our front-end repos, and all our branches get built, all of them. It just happens when you push your code. The build itself is created automatically. When I created my app with the generator, when I just push the repo, it's just going to show up in my continual integration environment. I don't have to interact with the operation team, or I don't have to configure it myself. There's a little bit of configuration, but the generator created that when I created the application. And like I said, the configuration lives with the app. It's not like in this centralized system. Most continual integration tools lately, like Jenkins and stuff, support this kind of workflow. But it's really key here. Like, you want to be able to own your build, but you also want to be able to create an application without having to worry about stuff. It should just work. Now, this is an example. I don't know, it's a little tiny, but it's an example of one of our build config. There's almost nothing to it because we want all the apps to build the same way, so it kind of inherits from a standard one. If that's not familiar, it's because we have our own build system. The interesting part here, though, is the publish section. It has the name of a branch, generally master, but it could be multiple branches. And anytime I merge or I push to one of those branches, all the build artifacts are going to be uploaded to, in our case, S3, automatically with every single build, and they're going to be versioned, regardless of if I'm planning on deploying or not. Why that's important? Our deploys are literally instant, and when I say instant, I mean kind of like 3 seconds. So how do we do that? Well, I just mentioned, the artifacts are pushed to S3 whether I want to deploy or not. They're accessible. Like, I could type the URL to it, and I'd get access to it. So when we do a deployment, and I use hair codes here, all we're doing is moving a route to point to the latest version of our HTML file. That's all it does. So if I want to roll back, it's also instant. All the versions are available. I can go back to any of them within seconds. And that's great because it gives us a lot of confidence. If I push to production and I realize immediately that I screwed up, I might only affect 1 or 2 users. Plus, since I'm only deploying my own app, because we split it in so many pieces, I'm only affecting a tiny portion of our users. The level of confidence that this gives you in our deployment, it cannot be understated. This is an example. That's the screen from which we deploy. And I'm really impatient. When I push that button there, it's going to deploy now, not in 3 minutes. I push the button, it's in production. And people are actually getting spoiled by that. We sometimes get messages of someone's like, my build to deploy is taking 4 minutes. I can't work that way. We really hear that at work. That's no joke. Now, our route configurations that are used by this deploy are also associated with the app. They're not centralized. I mean, under the hood they are, but the way we configure them is by applications. So the generator, when we create an app, will have the default, which is normally kind of the name of the app, and that usually works for us. But if people wanted to change them, the team, which is autonomous at this point, just changes it in their own repo. They push it, they build it, they deploy it, and now if you go to app.hubspot.com/something, foo-bar-baz, it's just going to show up there, and that helps a lot. Now that's for apps. What about libraries? Well, for us, libraries work like apps, except there's no deploy step. We have the same deal with the published branch. Every time you merge to that branch, it's just going to go and update. We automatically host with every build all the assets in there. So when you think about the library, there's JavaScript that you might be importing via ES6 imports or whatever module system you're using or anything. But there's also probably potentially images, or there could be scripts that I don't want to import. I want to link to them via script tags. Same deal with CSS. Well, with every build like that, the library is pushed to S3 too, so that I can just link to it. So I have 100, 200 applications, and if they point to the same image, each app does not redeploy the same image, so that we can get some benefits from caching and all that stuff. Now we have, again, we went from one application to hundreds. We'll have to run that stuff locally. We'll have to work on libraries locally. And we might have to run multiple apps locally to be able to mimic an entire flow. We need to make that easy. So how do we do that? Well, at HubSpot, we have tools that we wrote that we call Band and Asset Bender. And what they're responsible for, first, when I run an app using these tools, it will always use the right version of Node. We don't even depend on things like NVM to make sure the right version is there, because we found that developers really like using their laptop for side projects and things like that, and they'll configure them to hell and beyond, and they'll find a way to make it not work. So when you use Band, you're using a kind of isolated version of Node that's independent from everything. It will always use the right one. Also, when we run our apps, and that's like the most beautiful part here, I can pass at the command line a bunch of repos or a bunch of folders that contain application and libraries, and automatically it will spin up all the Webpack servers. And if you're adding libraries, it will automatically link all those libraries so that I can develop for them locally. If you've ever had to do npm link before, that's not fun. There's so many edge cases. And since for us, it's very common to work with like 10, 15 libraries and application at the same time, it has to just work. It also, when I'm done and I want to just work with my app, I don't want to like run a library locally, I want to run the published one. I don't want to have to think about undoing all those symlinks and stuff. So since we're running multiple apps locally, they're going to be running with a bunch of different servers. We use a proxy that's always running locally. And what it does is it automatically routes the apps roughly like they do in production. So if my Webpack servers are running, normally like maybe you'd go to localhost port 3000 and then you have 3 of them running. So they're 3001, 3002. Well, for us, we configure a proxy when the app is spin up locally so that they all go to local.hubspotqa.com/ whatever route I configured, and we try to closely mimic production there so that it works the same way. It's also responsible for if I stop serving one of those apps and that app has assets like images and stuff, they'll go to our CDN. So you can always just run one app so that it's much faster instead of running the whole world. So this is an example of how it looks like. So here I'm running the projects UI and CRM settings and a bunch of others. We don't see them because they're cut off. And all those routes are loaded automatically by the tooling. This could be done with any proxy. Like we have our own, but the goal is just like when the app starts, can send the configuration to the proxy so that it's routing them correctly. Essentially, the goal here is that I should be able to pick up any of our application made by like our 60, 80 front-end teams or something, and just be able to run them without having to be retrained and learn how they work every single time. Since we're going to have so many, we want them to be consistent in the development experience. So let's speak about consistency. Well, we believe in eventual consistency. We don't try to keep the entire world consistent all the time. And we're okay with that. Like our apps will not always look exactly the same if we make changes to our styles and stuff. They might take a little time before they all come up in sync. And this is a price we're willing to pay to be able to make changes a lot more quickly. But we do have the goal to eventually be consistent. So for UX, our solution to that is a style guide. We call it Canvas. It's basically a component library, the same kind that you see like think Bootstrap or Airbnb and stuff, but it's really comprehensive. Like we have several hundred components in there, and it's not just about components, but also patterns. The library will tell you how to handle, in this case, empty states, how to lay out your titles, how do we do a transition, stuff like that. It's used to be an issue at HubSpot where people would be like, your apps look like it was done by 60 different teams with 60 different designers. And it's like, that's because it is. So with Canvas and with our UI library, it helps a lot there to keep things consistent. But like I mentioned, if we upgrade, let's say, our button style to look slightly different, for a little time before all the apps get deployed, buttons might be different. But we're okay with that. So one advice here that I'll say from my experience, you cannot invest too much in a component style guide. Even if you're not at a large scale, you'll have multiple screens, you'll have buttons that need to look the same. You don't want your software engineers to have to ask the designer, what about this padding? What about this margin? That's like a recipe for wasted time and inconsistency. So this is a code that we hear a lot at HubSpot. People that tell us, I don't even remember CSS anymore. Like they exaggerate a little, but only a little. It's very possible to create entire applications essentially without knowing what you're doing. This is an example of an internal app that's not shown to our customers ever. There was no designer that worked on this. It was 2 developers over a couple of weeks. And it looks not bad. Like, it's not like the same as our production apps, but it's a pretty close approximation, and that's just one of them. We have a lot like these because we invested a lot in that style guide and these components. I mean, it's a React meetup, right? Components, yay! So it's not just about the UX, though. There's the consistency affect the developers. So what about code consistency? And that's something we've struggled with a lot. And then this wonderful project came in called Prettier. If you haven't used Prettier before, what it allows you to do is you point it at your source code. There's almost no configuration options, and it will output completely formatted code. I write my code on a single line, and then I command save, and it just reformats everything correctly all the time, and I have it in a Git hook. And that was great because we had a lot of trouble. I mean, software engineers will software engineer, and we had a lot of trouble getting people to agree on styles. We had a common one, but so since Prettier has so few options, we still had to put it up for a vote and stuff, but we were able to get people to agree on a consistent style, and not everybody adopted it, but most people did. And now, because like this runs automatically, I can jump from one team to the other, from one project to the other, use the same style, and it's pretty consistent. Now ESLint is delegated to correctness check instead of stylistic check. So it will check like if I'm trying to use a variable that I didn't declare, but it won't test for my indentation or something.
Spaces or tabs?
Spaces. So the next step when we talk about code consistency is libraries are a freaking pain in the butt. Sharing code across a lot of environment is really hard. Like the wrong abstraction is literally worse than no abstraction at all. For example, we have like internal apps, public apps, stuff like that that use different auth, and a library might be trying to wrap an API call, and if they're not careful, it's going to work in one environment and not another. So kind of our advice there is to be really careful about that. It's almost better to copy-paste code than to make a bad library. And that's kind of the advice I try to give to people. But that's not really practical. Like when you saw our style guide before, I don't want people to copy-paste that all over the place. So we'll still have libraries, obviously, and we have a lot of them. We have like 800 of them. So that brings us to versioning and how we handle it. We do major and minor version only. We don't do patch version. So major is breaking changes, minor is non-breaking change. So every time we, if you remember from earlier, we deploy our libraries every time they're merged to the publish branch. Well, every time that happens, we increment the minor version. And all apps, when they get rebuilt afterward, remember eventual consistency, not immediate consistency, they're going to pick up the latest minor. Majors are up 10, and for a while that was kind of a mess as we had like a ton of major versions. We're trying to kind of settle on one major for as many things as possible. There will still be inconsistencies during migration where we'll bump a major version to do a breaking change, and then we'll try to get people to upgrade to it. So we can rebuild the world. We have it set up that if I make a change, let's say to our style guide, I want to rebuild everything, I can do that. I'll like detect everything that depends on it, but it's completely optional. And the deploy itself is not automatic. We rely on the individual team to decide that things are okay, and when they're ready, they can deploy. We do have tools to nudge people, like if I make an update to our HTTP client or something for a security bug, it needs to happen now. We do have tools to nudge people saying, you really need to deploy like yesterday. So there's some stuff that must be consistent where this eventual consistency will not work. So for example, our nav, well, you don't want, like if I had a menu to it, you don't want it to be present when I'm on one application and then not be there when I'm on another. So how do we handle this? Well, remember when I said that the nav earlier was its own application? Well, it's kind of it's an app in the sense that it's served, but it's an injected script. Like the team that developed it, when they deploy just a script, and all apps have that script on them. So they're always running the latest version. Like it's just like a script tag. Think like a Google Analytics script or something. That's kind of how it works. We have places where we use iframes. When we have UX that need to show up inside an app, it's going to be an app and it's going to be loaded by iframes. Iframes are not great, but they're really powerful when it comes to making sure things are in sync across a lot of applications. We also like sometimes just use Ajax. Like you have a component, it's going to make an API request, or maybe it's going to load configuration from a JSON file that's hosted on the CDN, and it's going to use that to decide what it's going to display. That's a way to keep things consistent between apps, like without them needing to redeploy. Now about our build. Webpack needs to be consistent too. So what we do here is we hide most of it. So this is an example of one of our Webpack config, and that's actually like that would totally work in our environment. It just contains what can be different from one app to the other. And if you see, it's a bit small on the TV, but we require a factory function that you pass it those little keys, and it will return a fully baked Webpack config with all our Webpack plugins. We have like 60 plugins and custom loaders, and it's going to add all of them like that. Why it's important? Well, if you have published an NPM package before, if you've looked at some of the more popular NPM packages, you'll see that like they have a release for ES6 modules, for CommonJS modules, for ES5, for ES6, for TypeScript, for Flow, blah, 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 blah. Like, there's so many target environments, we don't want to deal with that. We want all our apps to have the same loader, the same JavaScript versions. Yeah, some people are like, I want to use the latest ESNext version, but we try to prevent that so that our libraries can target only a single environment. And this is how we do it. Now, when we talk about consistency, where does experimentation come in? Well, the good news is since all our apps are small, I mentioned that before, the blast radius are limited, and people are free to experiment with whatever they want. If they want to try a new framework, someone is like, instead of Redux, I want to use RxJS or something, or maybe I want to use both, or anything, they can do that. Some stuff is harder than others. Like if you want to use Vue or something, well, you have to re-implement our style guide. And again, this is a React conference, right? But so that is like the barrier for entry there would be a lot higher. But it's really a trade-off. We want people to still be consistent so that I can jump from one app to the other. So when people experiment, yeah, they're allowed to, but they have to limit the scope of it, or either convince everybody that it was a good idea so that everybody start doing it, or they have to roll it back or something like that. Now that brings us next to migration, the next big part of consistency. We're going to have breaking changes. I mentioned major version of library. How do we keep hundreds of applications consistent? How do we deal with migrations at scale? Well, automation is the solution there. Opening 100 pull requests for us should feel like a normal thing to do. So how do we do that? We have a tool that we call Mothership, and it's a cross-project task runner, essentially. At its core, it's kind of a self-service tool where teams can just go there and be presented with a list of tasks, like for example, upgrade Webpack or migrate away from this deprecated library. And they can click on a button on a link and then pick their project, and it's going to automatically open a PR after the code has been changed. But it's also a GUI, a tool, and I'll show it in a moment, where we can coordinate what we call missions, which is essentially a migration project across our environment. It's essentially a way to update projects at scale. So let's see what it looks like. So this is, it's a really new tool. Like we made that in the last couple of weeks / months. Here, it's a little blurry on the TV, but basically we have an interface where you can search across all our code base for projects that match a criteria. So maybe I have this dependency in my package.json. Show me all the projects that this match. And then I can select either all of them, or I can select a few if I wanted to just test stuff out. Then I can pick a task, and I'll get to what these are in a moment, but the one on the screen is deprecate UI label, which is one of our deprecated components. And you can do a dry run to see what it would run, look at the patch files that would be executed. And when I'm ready, I can click launch, and then I can watch the fireworks. It's going to go on our entire system, all of our applications that matched it, try to run the task, and if the task made a change successfully, it's going to open a pull request, and then I can track it, or I can ping people that did not merge them, or I can warn them that I'm going to merge them myself. And this is basically how we do these kind of migrations at scale. Code mods are our friends here. JS Code Shift is freaking awesome. If you've never used it, well, if I wanted to make a change in code, I want to rename a function, I could use a regex, or I could use search and replace. But what JS Code Shift let us do is use the AST, so like the parsed object graph of a file, to look like I can more easily check, find this specific function that came from this import called with these arguments, and rename it or something. And we can do that with a pretty high degree of confidence, like this type of static code analysis. And this is where things really allow us to scale. And it's a big reason for moving away from CoffeeScript, because the tooling for JavaScript ES6 is much stronger there. So essentially, project health should be a first-class citizen. We have a benefit here that since our applications are small and isolated, if there's tech debt growing in one app, we can more easily deal with it or put it in a corner or rewrite it. But what we don't want is to have tech debt kind of grow across all our apps. So a tool like Mothership is allowing us to keep everything up to date as much as possible. And we want to push that even further. Like what I showed earlier is an early version, but kind of what we'd like it to be is a dashboard where people can go and be told, you're using this deprecated pattern, or this version of React Router is 2 years old, you really need to upgrade it. And then they'll have linked to either documentation on how to migrate it, or a button that will automatically do them when possible, or maybe get them part of the way there. So cross-team efforts are much harder in this kind of environment, but work on individual teams becomes a lot easier. The leaf projects can move a lot faster. They're not bogged down by anyone else, but we still need to do cross-team efforts sometimes. So these type of tools make that easier. So sometimes, though, we found that the cost of splitting our apps is just too high. We have some much larger applications, and some of them, like, it would affect the user experience too much. Like, we have a CRM where you might be clicking between a customer and their profile like hundreds of times a day, and there's a lot of JavaScript behind it, for better or worse, and the refresh time would just be too slow. So we just can't, like, customer comes first, we just can't do that. So what are kind of some strategy that we're trying to figure out? Well, again, we're trying to figure this out. This is a hard problem for us. So some strategies there, the way we do the nav with injected scripts, maybe we need to use that more. High frames, with all their flaws, let us split a single screen in smaller chunks. And another thing that we're kind of looking into betting on is Webpack DLL. So if you've never looked at that, Webpack DLL is a really cool plugin. What it lets you do is have a fully independent Webpack build. You kind of point it on some code, and then you can say, these are libraries that I want to expose from this build. It's going to generate a manifest that you can then consume from a completely different build at a later time. And it won't need to rebuild all of that stuff. So this would allow us to have, like, part of a page that's owned by a certain team that have their own build it, and then another team consume it and be completely independent. It's not perfect because it's still going to load on the same page, so things like third-party dependencies, well, we won't be able to have multiple versions and stuff like that without any risk. It's not perfect, but we think it's going to work. So the goal here is to not solve for all architectures. Like, again, the monorepo world, single repo, a single page application is pretty popular. We don't want to solve for that at the same time as we're solving for our mini app at scale kind of deal. So let's talk about trade-offs. No architecture is perfect, right? So some issues we deal with on a day-to-day basis, pages do refresh. It's not as seamless as a typical single-page application. When you click on stuff, sometimes it doesn't just happen, like you'll see a flicker, and it does somewhat affect the user experience. We gain some velocity from it. There is repeated code, like I mentioned how we share assets, but code that's bundled up will be loaded every time I move from one application to the other. It's not really suitable for smaller system. Like if you're thinking that you're going to be building the successor to Slack, that's kind of like one screen. Splitting that in multiple pieces might not make sense. It's also a workflow that's kind of unfamiliar to people. We struggle sometimes with people that want to make everything an SPA because that's what they're used to. And the thought of splitting it in 5 might be foreign to them, and the benefits are not obvious. I don't give this talk all the time. And there's not as much community support. Running a lot of libraries and applications with tooling from the open source world is not great. I've looked at how people do it, and there are some efforts to make things like npm link better, but they're not picking up that much. Like they're not that common, and they're not that powerful. But we really think it's worth it. You get to keep the benefits of these small startup-sized projects, no matter how big you scale. Teams can be completely autonomous, and they don't need to affect each other when they're trying to go fast. And we don't need to scale everything. Our build tools code splitting for performance. Those are all things that we don't really need to worry about for most of our application. Our editors are still fast because they don't have to load nearly as many files. So let's wrap this up now. Microservices on the front end, it's kind of, I use codes because some of our apps are pretty large. They're just not as large as they would be. And that's a way to deal with growing pain when you're trying to scale just by abusing what infrastructure can give you. It's not for everybody. I mentioned some of the trade-off, but it's an option to consider as an opposition, so to speak, or as an alternative to monorepos. And that's basically what I've got. And I'd like to hear from people. This is my email address, my Twitter, and there's the Boston JavaScript that I'm sure you're going to mention later, Jeff. I'm sure there's some of you that are doing things like that. Maybe not exactly the same, but some tools that you've developed internally, some in the open source community that I might have missed that would help with these kind of architecture. And I want to learn about it. So ping me up.